Good afternoon, geometry, 7th period. So, you know by now I'm not here, and I believe that Miss Newman is your substitute. So what we are going to do today is video notes in class, and I want you to start in your red notebooks. Hopefully you already have those. If you don't, then after Miss Newman pauses the video so you can do the warm-up, then you can graciously beg her mercy to allow you to go get your notebooks because you need them for class today. All right, so the first thing I want you to do is this warm-up that you see on the board. Use the Pythagorean theorem to find the missing side. As you do that, I want you to see if you notice a pattern. One of the things about each of these triangles is that they are 45, 45, 90 triangles. So go ahead in your books and copy down these triangles and work the Pythagorean theorem for each one. Ms. Newman, will you pause the video for them so they can do that? Okay, now that you've done the warm-up, hopefully this is the answer that you got. That, 2 square root of 2 for the first one, 3 for the next, and 4 square root of 2. I also hope that you were having lots of aha moments and noticed that in each of these triangles, the legs are equal to each other, and that the hypotenuse is what? It is the leg times square root of 2. Okay, so that is the basis of what we're going to be doing today. I have another set of triangles that I want you to do to work the Pythagorean theorem on again and see if you see a pattern for that one. These triangles are 30, 60, 90 triangles. So this is another special type of right triangle that we have. Please go ahead and pause the video and work these out with Pythagorean theorem and see what you get and see what sort of pattern you find. You should have found that your missing leg was square root of 3, your missing hypotenuse was 4, and then your other missing leg was 3. Did anybody notice the pattern? So what's our relationship here between the short leg and the hypotenuse? How do I know that this is the short leg, by the way? I know that this is the short leg because it's across from 30 degrees, and that's my smallest angle. Remember the ascending side angle theorem from last semester? The smallest angle is across from the smallest side. So this is my short leg, the one across from 30. 1 times 2 is the hypotenuse. What about over here? Is my hypotenuse twice as big as the short leg? And here? It is. So that's a pattern. The hypotenuse is twice as long as the short leg. What about the relationship between the short leg and the long leg? Right here. Here's my short leg, here's my long leg. What did I do? It's 1 to root 3. So to get the long leg, I multiply the short leg by square root of 3. Is that true here too? It is. And is it true here? Yes, it is. So just as above, we noticed the pattern and marked it as each side was x and the hypotenuse was x root 2. That's a way of marking down our pattern. The pattern for these triangles can be marked out with x's as well. So notice I have my 30 degrees up at the top and my 60 at the bottom. It doesn't have to be this way. It just has to be that the longest leg is across from the 60-degree angle. So x is my shortest side. If I double that, I get the hypotenuse, and if I multiply by square root of 3, I get the longest leg. So let's go ahead and put that into some theorems. How do we say that? Well, we're going to use, we are going to call this the 45, 45, 90 triangle theorem. And this is just writing out the pattern that you've already discovered, which is in a 45, 45, 90 degree triangle, the hypotenuse is square root of 2 times the length of a leg. So the hypotenuse equals square root of 2 times a leg. And the way we write that out is the way we did for the pattern. Notice that our legs are equal to each other, and the two angles that are not 90 degrees are also equal to each other. You could pause the video here and then go ahead and copy this down into your notes. The other theorem is the 30, 60, 90 triangle theorem. For that, we say in a 30, 60, 90 triangle, the length of the hypotenuse is what? It's twice the length of the shorter leg, and the length of the longer leg is square root of 3 times the shorter leg. So as an equation, that would be hypotenuse equals 2 times the shorter leg, longer leg equals square root of 3 times the shorter leg. And I want you to pause for a second and get that written down. And then once you do, be sure also to copy the triangle that shows our 30, 60, 90 ratio. And there it is. Okay. At this time, if you could get your homework worksheets out, we're going to do a few examples from those. You will see on the board that I've written the ones that I want you to do. You may actually have some extra time, and so I encourage you to go ahead and do all of them because they don't take that long. In fact, if you do have extra time, I'm going to have Ms. Newman say, yes, go ahead and do them all. In the meantime, let's look at some examples from your worksheet. So, first of all, let's look at number 4. Number 4 is what type of triangle? It's a 30, 60, 90 triangle. Here's my 30 degrees. So that makes 8 my short leg. That makes X my long leg. And it makes Y the hypotenuse. So if this is my short leg, what's the long leg? The long leg is going to be 8 square root of 3. The hypotenuse is twice as long as the short leg, so that makes it 16. Okay, number 6. What type of triangle do we have there? Number 6 has 2 legs that are congruent to each other, so that makes the angles congruent, so it means it's a 45, 45, 90 triangle. Now, this one is a little bit trickier because we're going from the hypotenuse to the leg. So that means instead of multiplying by root 3, which we would do if we were going from the leg to the hypotenuse, we have to divide. So we know that X, I'm going to divide by square root of 2. X equals 10 divided by square root of 2. Now here's the thing. In geometry, I never want you to leave a square root in the denominator. That's not a finished problem. So at this point, you have to rationalize the denominator, which means we're going to multiply the top and bottom, the numerator and the denominator, by square root of 2 over square root of 2. When you do that, you will get 10 square root of 2 over, what's root 2 times root 2? That's 2. And then you reduce that and you get 5 square root of 2. So X is 5 root of 2, and so what does that mean Y is? It's also 5 square root of 2. Okay, one more example, and then you are on your own. Again, if you need to pause at some point, just ask Ms. Newman. Okay, number 8. Notice I'm doing the evens with you as examples. That's because I want you to work the odds. With the exception of number 13, I want you to replace that with 12, since 13 didn't print correctly. And also be sure to do number 2. Okay, what type of triangles do I have here? Well, since these are congruent, I know that these are 45, 45 right triangles. So that means that this side and this side are congruent. Same thing down here. These two angles are congruent, so I know that these two sides are congruent. So to get from the hypotenuse to the leg, I'm going to divide by the square root of 2. So 14 square root of 2 divided by square root of 2 is just 14. It's the same thing over here. These two are equal, so I know that X equals 14. Y is equal to X, so it's also 14. Z is the hypotenuse, so I'm going to multiply by square root of 2, and that makes it 14 root 2, just like the other side. For your homework, be sure to pay attention to the directions. If it only takes you one step to solve it, you can just write the answer. If you need more than one step, like rationalizing the denominator, then you need to show me your work. Don't do that in your head. All right, have a great rest of your period. Focus, get your work done so you don't have homework, and be good students for Ms. Newman.